Well, thanks for coming out this afternoon. Joey and I want to chat with you this afternoon about benchmarks to baselining. All the cool terminology, all the cool tests, and all the cool things you can do with it. So my name is Mark Aktimichuk, but I'm known as Mark A. And I'm a performance specialist in the field with VMware here, which means your SEs out there can get a hold of me for kind of performance-related questions. And I'll let Joey introduce himself.
Yep, and I'm Joey Dickhans. I'm a performance specialist in the technical marketing organization at VMware. And we'll just plow on into this. All right, so standard little disclaimer, but there's nothing really confidential in this presentation. So anyway, I'm going to go over just some of very basic information. It might be somewhat obvious to some people, but hopefully you'll get some tidbits out of it. Just, what is a benchmark? A couple of different types of benchmarks, some of the studies we've done. And then Mark will go into even more of some of the myth-busting with benchmark data. All right, so just basic definitions here. So what's a workload? We'll start off on the first basic thing. So a workload is any sort of work, a task, a process that you make a computer do, at least in computer terms of what a workload is. But it has no structure. It doesn't have any rules or anything around it. So it doesn't specify how well the workload runs. It's just basically work. And a benchmark puts a little bit of structure behind it. So a benchmark will add some rules, maybe put in a response time criteria, and then it has a scoring mechanism so you can tell how well this workload was running in your environment. And hopefully the benchmark is using the workload and putting those rules around it in order for it to mimic some real life, in application or environment that you're trying to study. And then simply, what's a baseline? Well, a baseline is just a benchmark that you've taken a snapshot of, so you've run the benchmark once, and you got a historical data point to compare against. So we can use the baselines as a comparison point of our little benchmarks. All right, very simple. So what makes a good benchmark? Well, that's a good question. There's actually really two categories, I think, of what makes a good benchmark. One is how well is it real life? So how well does it model the real life application or workload that you're trying to analyze? So that sort of goes into how well is it real life? How well does it focus? If it's got a limited scope, is it monitoring the things that you're interested in, or is it monitoring a bunch of other things that you're not necessarily interested in? That might not be a good benchmark for you. And then the other category is how accurate is it? So is it repeatable? Can you run the same benchmark again and get the same number? If you can't, it kind of gives you a not as so warm, fuzzy feeling that this thing is as accurate as you'd like it to be. To go along with the accuracy, having a documented scientific methodology, so you can go through very systematic steps of running the benchmark and collecting the data, that helps in getting accuracy. And a mature benchmark, something that has been around for a while, that helps in being able to analyze what you're trying to measure correctly. Sometimes early benchmarks, they've tried to collect a measurement, but in doing so, they've actually inflicted, some other performance element into it. So they're no longer measuring what they're thinking they're measuring. A mature benchmark has most of those bugs worked out. And ultimately, what you're trying to get is a real-life example that's accurate, so you can do apples-to-apples comparison. Now, Mark maybe put this bullet item on the slide. Benchmarking is not the same as bench marketing. I'm a little offended because I am in marketing, and we love bench marketing. But I think the point here is that for benchmarking, and we know what the benchmarking ones are, these are the unrealistic, I'm never going to do this in real life type of benchmarks and studies. Take them for what you can get out of them. So, I've been touting our 1 million IOPS study. We had so much hardware into that, and we were caching things on the back end. It's a great study. It shows how well vSphere is able to handle the workload. It's not necessarily a realistic study on how much storage you would have to do in order to handle that, but it makes a good number. Anyway, the whole goal of doing benchmarks is so you can make some intelligent decisions here. Just some types of benchmarks. There's lots of different ones. Resource types, so resource-specific benchmarks that'll study just storage or just memory or just CPU. We've got virtualization benchmarks that study the virtualized environment. We've got application-specific benchmarks. We've got little micro benchmarks. Of course, we have the industry standard benchmarks that you probably have heard about. And then again, we've got a lot of customers who build their own for whatever reasons, and we'll talk about those as well. All right, another little simple slide here of just what do benchmarks typically measure? So typically you'll see a benchmark measure concurrent number of users, response time, CPU utilization. We're now seeing, because of green initiatives, power usage as a big key for benchmarks. These are the things they'll measure, and these are the things they'll typically score on. Now, things that they might not measure or collect. So if the benchmark has a score that is relies on CPU utilization, the benchmark kit itself will generally collect that and put it into a report for you. But things that it generally won't collect are like EXX top data, because that's at the virtualization layer. So when you're running these benchmarks in your virtualization layer, it might be good and probably a best practice to grab EXX top data while you're running the benchmark, so you have a whole view of what the virtualization layer is doing while the benchmark is running. Other things that you might want to consider grabbing if the benchmark doesn't grab it itself is, if you're using a Windows or a Linux, grab the in-guest metrics. So what does the guest think is going on in the environment? You're also grabbing the EXX top, so that's what the virtualization layer, but you also need to grab what the guest is thinking is going on. And then grab any system event logs inside the guest, so you can detect a failure that might have occurred at the same time that might have caused a performance issue in the benchmark. And in order to get the accuracy that we want out of a benchmark and to make sure that you collect everything that you need, very highly recommend doing scripts of some type, batch scripts, shell scripts, so that you can collect all that data. So if you're going to run a script, to run the benchmark, to kick it off in the same way, kick it off so that you run scripts to collect the data in the same way, so that when you get to the end and you have a bunch of different runs of your benchmark, you didn't accidentally have one run where you forgot to collect the EXX top data. If it was all in the script, it would collect it automatically for you. And we've got wonderful scripting tools, PowerCLI, things like that you can use to script in. And key note there, make sure your time is synchronized across all your virtualized environment, your VMs and the EXX hosts. Trying to figure out what went on at different times if the clocks are off is a nightmare. Anyway, just another simple slide here. When you collect all this data, the obvious things to look for: missing data, failures that might occur in the log files, variability, variance, from one run to another run, also concern. Things that you might want to look at are correlations and metrics. If all of a sudden you see CPU spike at the same time networking spikes, maybe you want to look at that, what caused that. Really high values or really low values might be possible bottlenecks or resource limits. And then I think the key ones here are challenge what you find, right? So if you find something that looks too good to be true, it might really be too good to be true. Go look at that in more detail. If it looks a little too slow to be true, look at that as well to see what might be misconfigured. And then validate what you found with outside people who might have a little bit more experience or have a different take on it. All right, so now I want to just jump into some of the benchmarks. And so we'll start off with the virtualization benchmarks here. So there's two big virtualization benchmarks. SpecVirt announced their virtualization benchmark last year. SpecVirt, nice benchmark. VMware was a part of the committee that helped design it. Nice things about it, it's vendor neutral, so you can run it with any hypervisor. So if you want to compare one of those other ones, why I don't know you would ever want to compare it. But anyway, if you wanted to, you could. It runs with all the other vendors. It's an industry standard benchmark, so there's no bias in theory, right? I mean, we were on the committee that helped build it, but of course all the other people were as well. Anyway, the cons, however, are it is a licensed product. It's an industry standard benchmark. They make their money that way. And the other big one is that it has a loose software stack configuration. Now, when I mentioned, what makes a good benchmark, I kind of alluded to the fact that we wanted it to be a focused benchmark, just what you want to look at. In a loose software stack, what I mean by that is that they allow you to change pretty much any of the workloads. The workloads are specified, but exactly how you get those workloads to run is not. So, like for instance, you can pick what type of database you want to run with. So it could be an Oracle database, it could be a MySQL database, DB2 database. You can run what type of different application server you want. You get to choose all those different software stack components. So it makes it very difficult to compare one run from another run when so many things have changed. What are you comparing against? Are you comparing the hypervisor, or are you comparing against the database that changed, or the application server that changed, or the hardware that changed? So it's a little bit challenging to find those comparisons. Now, VMmark is our benchmarking tool for the virtualization environment. Nice things about it is the first multi-server data center benchmark. So in this benchmark, we actually have 2 EXX hosts as part of the benchmark. SpecVirt only has a single server. Now, it includes the infrastructure workloads. So, all these nice little infrastructure workloads are already pre-built into the test harness. It's free, however, with the little star there. VMware provides VMmark in the test harness for free. However, some of the tools like Exchange is in there, Windows licenses, those type of things would have to be procured by you guys. And then the cons, however, is that it is VMware specific. So you're not going to be able to use VMware's VMmark to benchmark other people's hypervisors.
And Joey, just to jump in on that one, one thing I kind of wanted to do is set the scale for these benchmarks a tiny bit for you, because I get a lot of questions about, hey, I want to go run VMmark, and I'll just whip it up on a Friday afternoon. And the reality is, it's not like that. When you think about having to saturate 2 hosts and the number of machines you have to create and the implementation of the harness and things like that, there's a lot of complexities in there. So just quickly to set the scale, this isn't a day activity. This is probably more like a week or a few weeks type activity. This is the investment that goes into a good benchmark run. Right. And just to go into that, so yeah, this is not a day activity. This is a lot longer than that. And that's because it's made up of actually 8 virtual machines in a tile. So SpecVirt and VMmark kind of look the same in the way they've architected their benchmark. They use tiles, so a tile is a collection of 8 virtual machines, and then they layer tiles on to make more and more workload in the environment, and they basically get up to 100% CPU saturation in the environment. Now, the tile is part of what they report for the score, but really there's a score as well. So the score is made up of all the different individual workloads. They collect measurements from those and come up with a score of how much work is being done by those workloads inside the tile. But the tiles, those VMs inside the tiles are a set size. So the VM size is set. You're not allowed to change that. So in order to get more work on the server, you have to put more and more tiles in the environment. And so that's sort of how it's designed. And then also a new thing in VMmark 2.0 is it also tests infrastructure tasks like storage vMotion and vMotions, because those are more important to you as well, and it should be part of a virtualized benchmark, but not in SpecVirt, only in VMmark. And then, like I said, you'll see that the score is reported as the score at so many tiles. The at so many tiles is kind of an informational thing. It's not really as important as it needs to be. It's the score that's really the important thing. All right, so now VMmark 2.0 is mostly a hardware vendor benchmark, right? So mostly at the time, these are the hardware vendors investing the time to do this. It is a lot of time to set up. But it is a workload that sort of simulates a very diverse data store type workload. So you can use it to test other things, and our VMware engineers have used it to test certain things. And this is one of the studies that one of the VMmark engineers used to test the difference between SSDs and regular traditional storage in a virtualized environment running VMmark. And they found that 25% better improvement in the score when running with SSDs. So interesting little tidbits of information that you can get out of running benchmarks on their off-label uses. All right, so now I'll go into some of the resource-specific benchmarks. You probably are all very familiar with this tool, so iometer or iometer, however you like to pronounce it. It's pretty much the de facto standard for I/O workload generator. Now, again, it's a workload generator, so it means it doesn't have the rules around it. So you can't just say I ran an iometer benchmark. It doesn't quite mean anything until you specify some things like I/O size. What were you measuring? Were you measuring latency? Were you measuring throughput? Those type of things. What was it? Read, write, sequential? Those type of elements to the workload. Once you give it that, you can kind of make a benchmark out of it. It's great. It runs on Windows and Linux. It's free. It runs on a single server or multi-server. It's pretty easy to use. All right. As I was mentioning, in itself, it's a workload. So in order to give it some smarts and make it into a benchmark, you need to have a profile. And so here's a URL. Now, these slides are available after the conference, so you can get to that URL. So you don't have to jot it down right now. But anyway, you can also Google it. This little blog article provides some of the profiles for databases and web servers, so you can use those profiles as sort of a ready-built image of what a database storage workload would look like, and you can use iometer to generate that workload and benchmark what your database, just on the storage aspect, could be driving. Now, when you're running a storage workload, make sure you're doing things like load balancing. If you need to have more throughput, make sure you're using multipathing correctly. We do highly recommend the PVSCSI device driver. That's the Prepare Virtualized Device driver. So make sure you're using that, especially if you're doing a storage benchmark.
Things to look out for, of course, I/O contention, disk shares. If you've got an environment where there's other virtual machines, generally we like you to just benchmark one at a time, but if you are doing something, make sure your disk shares are set correctly so you're not giving storage performance to somebody else accidentally. Other features that are great in production might not be great for a storage benchmark if that's all you want to do. So like storage I/O control and storage DRS. Storage I/O control might throttle back your workload if it doesn't have the correct number of disk shares or if you're going over a certain amount of latencies. So that might not be what you want to test. Storage DRS might actually detect that you've got a large workload in one data store and decide to migrate you. So you might want to think about disabling those if you're doing a storage benchmark. All right, moving on to networking pretty quickly here. So NetPerf is pretty much the de facto on that one. There's not too much in the way of tips and tricks for networking, at least not if you're at my level of networking knowledge. However, jumbo frames, the other big one that we've been seeing recently is the converged network. So if you've got a converged network and you've got storage and traditional TCP/IP over your single Ethernet card, be careful that you're not going to hose your storage, so don't run this on a production environment for sure. And then also make sure that you are aware that your storage workload is also running over that NIC if you've got a converged network. And then the VMware features to keep an eye out on, network I/O control, networking limits that we have, and then multipathing at various different levels. All right, and then CPU. These are the next two are kind of interesting, CPU and memory. CPU, there's a bunch of different type of workloads that are CPU intensive. We picked this one. It's W prime. All it does is it calculates the square root for the first 32 million numbers or the first basically 1,000 plus million numbers. It's going to just stress the CPU and tell you how fast your CPU is running. Now, it might be interesting when you first deploy the server to just see that it seems to be running at the right speed. Once you've deployed the server, any CPU issue that you're going to have in your environment is going to be due to contention, most likely. And contention is going to be visible inside vCenter. So you really don't need to benchmark your CPU again, at least with tools like this, after any changes, after that first initial deployment. Now, when you're doing tips and tricks for a CPU benchmark, the key one is to look for contention. So look for context switching would be the next big one. Context switching would be the vSphere scheduler is having to move you from one processor to the other. So that's one thing you might want to look at as you're running this. To get away from that, you could do binding of the CPUs. We do recommend enabling hyperthreading, enabling max power max performance instead of on your power savings inside the BIOS for your physical server. Now, we had a question yesterday in one of the talks about we recommend hyperthreading being enabled for performance studies, and yet sometimes our performance engineers actually disable hyperthreading. And the question was, why are they doing that? And generally the reason why they're doing that is they were trying to figure out what is the CPU utilization of whatever benchmark we're doing. And the reason why we have to disable hyperthreading sometimes is that CPU utilization numbers get a little funky when we allow hyperthreading because some other process could be running on the hyperthreaded twin and affecting our performance. So the way we can get around that is just disable it. And so now we can tell what real true CPU utilization is. The same thing also goes for turbo mode. So that's the ability to detect that you actually can overclock your CPU. Sometimes we've disabled turbo mode as well because we want to be able to get true CPU utilization and not have to worry about, well, maybe that CPU was actually overclocked at that time. All right, and then like the CPU one, we also have a memory one. A little tidbit here, so we picked RAMspeed as the open source memory tester here. Most of the memory testers that are out there, again, only test a very small amount of memory. They're looking for how much throughput can you get to the system memory. So they're not really touching all the memory in the environment. So this is another one where you would run it at the very initial deployment of your physical servers. Once you've got the virtualized software on there, run it once, see that your throughput is good. After that, any memory issue you're going to have is going to be memory contention, and that's going to occur inside vSphere, and you're going to be able to see that inside vCenter. So you'll be able to see swapping that's occurring inside vCenter. So you probably don't need to rerun any memory test, at least like a RAMspeed type test, after the initial deployment. Again, some of the memory features that we have, vNUMA, if you've got a large NUMA environment, a large server that's using NUMA. Memory limits and shares, transparent page sharing, make sure that those are enabled. Memory compression, host cache. If you are going to be doing a memory test, obviously you don't want to be swapping, so make sure that you've set a reservation for the amount of memory that you're using. All right, and so we'll jump into just a couple of application-specific benchmarks. So here's some fun ones. DVD Store, which is originally designed by Dell, and it's an open-source simulation tool for online e-commerce site. The nice thing about it, it's pretty fairly easy to set up. It's got a nice little GUI that sort of guides you through most of the steps. It's also still actively being updated. If you go out there and you just grab random benchmarks, at least some of the open source ones, they're sort of like side projects for random people, and they work on them for a year or so, and then they lose interest, and the community isn't there to keep them going. DVD Store, it is still the side project with quite a lot of people, but they're at least very active on it. It's still maintained very, very well. Runs on Windows and Linux. The potential cons are that it does require just a little bit of DB knowledge. There is a guided setup to sort of set you up most of the way for most of the databases. There's a little bit of fine-tuning that needs to go on in the database that you might have to have some DB knowledge. And the other thing is there's a guided GUI, I believe, but there is no real GUI, so it's a con and a pro as well because you can script it a little bit. All right, just another one, SAP SD benchmark. So this one's great if you've got an SAP environment, obviously. The key things about this one is it does very well stress SAP's workloads. It is also a good generic benchmark for e-commerce type of things, ordering from a stock and processing that order. The pros are industry standard, very well supported, mature benchmark, lots of data points out there for you. It's very application specific, so if you've got an SAP one, this is the one you're looking at. The cons are, as a regular customer, you kind of have limited access to the test harness. The test harness is really for partners of SAP to run, and so most customers aren't going to be able to run this themselves, but there's a lot of data points from the partners out there. And the other con for a virtualized environment is a lot of the benchmarks are a single VM, so the data points that you see out there are single VM, and we prefer to see larger environments with two VMs or three-tier environments. All right, another one that we've got is Exchange Load Gen. So this is if you're going to try to benchmark your Exchange servers, see how many email boxes you can get on an Exchange server. Again, pretty easy to use. I believe it's completely free from Microsoft as well. So nice little tool. Things we've done with it, however, we've used it as just a good benchmark, a good workload for some of the other testing we'd like to do. So we ran this study with Exchange Load Gen to compare 4.1 performance to vSphere 5 performance. And the two key takeaways here are the last two bullet items. We've greatly improved vMotion capabilities in 5.0 compared to 4.1. So we had a 30% reduction, more than 30% reduction in a vMotion of a virtual machine running Exchange Load Gen at high levels. And we also had an 11% reduction with storage vMotion. So we were able to use some of these benchmarks and, again, off-label methods to be able to run the benchmark as basically a workload, as a stress for the virtual machine as we do some other testing. And I'll just go back once. When you are thinking about mailboxes and Exchange servers and things like that, storage, it still is one of the biggest causes for performance issues in the virtualized environment. So whenever we get an Exchange problem, it's generally either the storage or they've just misconfigured the Exchange server. All right, I think this might be the last one. We've got Oracle SwingBench. And I like this one is because, again, it's very specific to Oracle, but it's a big application that's out there. And it's very cute. It's got nice little charts. It's very fairly easy to use. It's written in Java, so it's very portable, and it's free. And again, it doesn't just have to be Oracle, so this is another off-label use of it. Any database is pretty memory-intensive, so we use this as a good memory-intensive workload and benchmark for our process for other internal testing. This time we were trying to test out host cache, which is a new feature in vSphere 5. So we were trying to compare what host cache, the performance of host cache versus swapping, and so we used Oracle SwingBench for that because of the memory intensitiveness of Oracle SwingBench. So we had 12 virtual machines all running, each one of them running Oracle SwingBench. We powered them up on a single EXX host. We gave them a certain amount of memory, and then we started reducing the amount of memory they had, which caused them to swap. And in one case, they swapped out to physical disk. The other case, they swapped out to a host cache, which is on SSD. And they plotted the little performance there. And you can see the bars for the host cache are just significantly higher than the bars for the poor little swapping. So we had 600% better memory latency when we were using the host cache, swapping out to basically SSDs instead of swapping out to physical storage, rotating storage. And we had about 76% better application throughput. So that would be the score that we got from the Oracle SwingBench benchmark. All right, and so the last type of benchmark that I want to talk to you about are micro benchmarks. I kind of like micro benchmarks. They're lots of fun in some ways. But micro benchmarks are designed to measure very specific small pieces of code or a task, very small, right? And the idea here is that if you can improve something that's very small, but that's used very, very often, then even though you get a little gain out of that small thing, since it's used so often, you can actually make a significant performance gain in the overall environment. So that's what it's trying to do. It measures something at a very fine granularity, just a tiny little thing. So this could be like a spin lock inside of your program. You measure that spin lock, and if you can improve that spin lock that's used multiple times in your application, you can improve it by just a little bit. That could be a great gain for you. And here's some of just the common things that we've seen as a micro benchmark for an application or a virtualized environment. DNS queries, how long are those taking you? Active domain authentication, individual SQL Server commands or SQL query commands. Basically, any function or routine that's called often, you can basically use as a micro benchmark. And this is actually, we've seen this occur many times with customers. We had a customer recently who basically called saying that we've migrated an application over to the virtualized environment and the performance is just abysmal now. You got to take a look at it. It doesn't even start up very quickly. And we looked at it and we said, I don't know. Are you sure it's exactly what it was in the physical environment? You didn't change anything? Oh, yeah, absolutely. Everything's exactly. Well, apparently they fat-fingered the DNS server, and it was timing out. So they had a lot of DNS requests in the very beginning, and every time they had made an attempt for it, it was a 1-second delay because it had to time out for the first one and get to the correct one in the next entry that they had in the DNS. So micro benchmarks are interesting. We also use them very extensively inside VMware. So every night we run about a couple thousand micro benchmarks against our own code. And we look for regressions in performance because we want to catch those before they get any farther in the product. So every night, thousands of benchmarks are being run against the product. Our engineers review that the next day and highlight the ones that seem to show no regression and go back into R&D to address those. All right, so just some guidance here for making your own custom benchmark. Again, the keys here are we want it to mimic real-world scenarios and make it as accurate as we can. So mimicking real-world scenarios, feel free to use more than one workload or benchmark if you're trying to create your own. You don't have to just pick one and focus on that. Typically, a real-world workload does stress multiple things. So you could use iometer and netperf at the same time, or you come up with DVD store and whatever other benchmark you want to run at the same time. Vary the amount of workload to measure performance at your typical level and at your high water level. Some customers just run it at the high water level. That's more like a stress test almost. Also measure what your performance is at your typical average workload. And then there's a trade-off between the randomness and real life of your workload, right? So the more random your workload is, that's probably more real life scenarios. However, there's a trade-off on that. That also makes it a little bit more difficult to be repeatable if there's randomness in it, which in order to compensate for repeatability, you have to make your test run longer in order to average things out. So there's a little bit of a trade-off between those four elements. The next one is measure what matters and don't measure things that don't matter. Now, I can kind of phrase this a little bit differently. Feel free to go ahead and measure and collect measurements from things, but don't score it. Don't make it part of the benchmark score if it doesn't really matter to you. And that's because you want to compare things that matter to you. So if you run the benchmark and it's collecting data and scoring and providing a value, a score for things that don't matter to you, you have to then discredit that when you start making the comparison. So you have one run that had 5,000, you had another run that had 6,000. You think higher is better, but then you look at the 6,000 and say, oh, but yeah, in that score is something about latency, and I don't really care about that one in this particular environment, so I have to discredit that number. It makes comparing things a lot difficult. So make sure that when you do make a score, make sure it's scoring only the things that you really care about. And then definitely, in order to have a good benchmark, you have to have defined rules. Make sure you have load levels, quality of service, all those type of things defined up front so that you, again, aren't making any changes at the last minute, discrediting the scores that you've already collected. All right, just another couple recommendations for benchmarking. We've already talked about some of these. Definitely automate your scripting, automate or script everything so you do collect everything and are as consistent as you can be. Frequency, generally once a quarter or after any major change is probably a good idea for storage or networking. The CPU and memory testing, those specific storage, those specific resource ones, you probably, like I said, only have to do them at the very beginning. Historical data collection, collect as much as you can. I always think that having more data, especially for the historical data, is interesting to see how you've grown over the years. Definitely, you'll probably want to collect at least 1 year's worth of data and keep that around. That's probably going to be valuable to you, just to see the seasonality of work. Recommendations at the physical layer, so definitely we want to make sure that your power saving settings are set for max performance at the BIOS level. Use dedicated hardware. Please don't share hardware. That's going to make your repeatability of this performance study a little bit more difficult. Get measurements at a fine enough granularity, but not so fine that you start causing performance problems by the amount of collection that you're doing. So don't overdo it on the collection of data. And then be mindful of snapshots. So it's very tempting to create a virtual machine, set up your benchmark in it, snapshot it because you're going to run the benchmark, and you want to be able to revert back to the base that you had before you ran the benchmark. So you take a snapshot, you run your benchmark, and you restore the snapshot. A snapshot does have some overhead. So if you're doing a storage study, you're going to be testing some of the overhead of that snapshotting. So that's not what you want. You're going to have to think of some other way. Now, generally, this is snapshotting at the vSphere level. Generally, snapshots at the storage array itself are a little bit less overhead, so it might be safer to do it there. But be mindful of that. And then lastly, remove the bottlenecks as you go. So, if you see that your benchmark is bottlenecked on storage, try to work around it. See if you can put a RAM disk or something there to get the storage out of the way, just to see where the next bottleneck is. So this is great for what-if scenario testing. So before you go to your CTO or your VP asking for a larger storage array when you think you have a storage bottleneck, it'd be good to do a little bit of what-if scenario to see if that storage is not really the only bottleneck, because you'd hate to have to bring in that very expensive storage array and then find out, 2 seconds later I got bottlenecked on memory. So that won't be a good trip to the VP after that. All right, now I'll turn it over to Mark to talk about how some of the benchmarks that we've run have been busting myths.
Thanks, Joey. So the one thing I just kind of want to reiterate with what Joey covered there is we blazed through this. The session's pretty tight. We have a strong passion for a lot of this. It's hard to fit it all in. But what I want to portray or get across is that benchmarking is a pretty interesting science. You have to be very careful with it. You have to be very deterministic with how you use it. And then it becomes valuable for decision making. So don't underestimate it. We blazed through it, but it's not something you can easily do overnight kind of thing. Put some real effort into a real benchmark. So having said all that, we take all this away now, and so let's touch on some of what we've done with inside VMware. You guys have probably been bored to death of this slide here. But again, I just want to stress kind of the capabilities of the vSphere 5 platform now. And what we have to do every time we release a new platform is, again, let's start to push the envelope again. Let's see what we can absolutely do. So a big myth that pops up right away here, no one's migrating applications. The differential between physical and virtual is still too big. How many people would agree with that in here? I flew up the false really fast to say, okay, good, you're all following my lead. The reality is there isn't that big a differential anymore. The tests that we continue to do, and this was a data point that we used the SAP SD benchmark, is that overheads here again are on the order of, we see 10% overhead, 7% overhead, and we continue to shrink those. We'll have some more data shortly that shows generally 3 to 5. Now that's pretty insignificant. Keep in mind that the effort to display that 5 or 10% was huge to generate this. So we're talking about big apps, big scalability. This was a different workload, so we're talking about vSphere here. And what I thought was interesting in this test, it's a tiny bit older, this was under ESX4, but the one configuration in the middle here, although we don't typically exceed 5 or 10% overhead, again, we actually beat native. And that was because we do some interesting things around scheduling. We were able to make some more intelligent decisions. We don't claim that you're going to outrun physical, but it just goes to show you what benchmarks can do. So the other thing we had to do with that test is we had to figure out why that was the case, challenge the data, like Joey said. And ultimately it came down to, like I said, intelligent scheduling. So the other myth we get here is, we can't support running typical database workloads, and especially not large databases. And that's obviously not true. And here I want to challenge that notion again that says, what is a large database? So who here in the room can put up by their hand and tell me that their database is doing more than 5,000 IOPS? Anybody, one hand? Is anybody doing more than that? A couple hands. How many people don't know for sure what their databases are doing? Okay, and see, that's pretty common. So when I hear people say, oh, I can't do that, I challenge it because I say our data set here, this is from our capacity planner system, we drew out all SQL servers and we said, what's the average SQL server doing that we're aware of? And generally, it's the orange bar. The blue bar was the capabilities of vSphere 4. So we can see that, again, what we think is large typically isn't. And we have to pull upon this data. We've got to pull out these benchmarks to kind of prove that. So we have a lot of capability in the platform that's not being touched yet today. This was another benchmark we did here. This is an unaudited result. This is just something we did internally here, was using Oracle. And ultimately what we wanted to show with this test was kind of scalability of the virtual machine. And what we're always looking for in our platform is good linear scalability. We're looking to measure some overhead. Here we can see on the 8-way side, yeah, there was absolutely some overhead involved. But what was really interesting about this result, what was really important to us, was how many transactions per second were still occurring. What was the latency and what was the scalability? The fact here is we picked what were important data points to us, and although we displayed a little bit of overhead, what we were able to show is that, again, what's important to you, transactions per second. And so this result, again, we do a lot of testing inside, and just touching on some key data points here, know that you can come back and reference this stuff instead of reinventing the wheel all the time. But it speaks to Joey's point about picking what's important to you, picking the right workload, and getting what's important out for your business. Okay, so another myth here. We can't support high I/O. I kind of ruined it because I put up 1 million IOPS here before. I mean, a pretty amazing screenshot. Now, to Joey's point before about some of the benchmarking versus benchmarketing, we continually refine these results. Everybody should always challenge results we have. This was done with an 8K block size, so it's very realistic as compared to some of the tests we've done in the past, other people do in the past with a 512-byte block size. But regardless of how some of that testing was done, when we look at these scalability numbers through the roof, nobody can actually achieve these today. There are no workloads today that push this kind of envelope. Again, to put this in scale here, this test required an EMC VMax, a single array, 960 fiber channel disks on the back end to support a lot of this. I mean, that's probably a $20 million array. We saturated it with one ESX host. We achieved this result with one ESX host and 4 VMs on it. Just an interesting data point. Coming out of that test, we wanted to measure kind of the performance difference between our PV-SCSI driver, our paravirtualized disk driver, versus the standard LSI driver. And out of this result, I apologize, the scale on the right-hand side is supposed to be milliseconds. It's not I/O bandwidth, so don't pay attention to that part. But what we again showed was a higher efficiency for the PV-SCSI driver. So here again, another good example of using a benchmark to deterministically say, hey, PV-SCSI is the right disk driver to be using for I/O-intensive workloads. And the last myth here is, vSphere performance is similar to that of its competitors. And so jumping out and looking here, this was a study that we had done with TG Group there. And basically what we outlined here was using the the Dell DVD store workload is that we can see much, much higher scalability on our platform and the capability to continue to host larger consolidation ratios. And I call it out as a bit of an interesting competitive point because everybody's always wondering, what's the right platform to be on? How can I test for things like that? And so this was using a real-life simulated workload against some of the other competitive platforms. Another valid, good use of a benchmark. So what does this all mean now? Effectively, benchmarks have proven the virtualization capabilities. Anybody raise their hand? Anybody's worried that the virtualization platform's too small, too slow, not going to work out yet? Anybody that's not brave enough to raise their hand, come see me at the end. We can continue our education here. But the fact is, there's a team at VMware that's dedicated to doing this kind of work, to making sure that this data is available, to make sure that this platform supports your business positively. I think today we have about 99.99% viability with a vSphere 5 platform under x86-based workloads today. Normally, if you would go out there and say, can you run X application, there's probably a client already running it. We've probably done a benchmark on it if there actually is a benchmark for that workload. And it all means that this data provides you confidence. So yes, benchmarks are complicated here, but why reinvent the wheel? Use the data that's published. It's not going to change each time. A good benchmark is reproducible. And then, obviously, now that you have all this, now that you know you can do this, is to migrate methodically using kind of your own baseline. So let's talk a little bit about that. So quick and dirty, how do I achieve this? So I'll always suggest make sure, again, like Joey said, we analyze all the resource dimensions. When you want to baseline an application, you need to know what it's doing in the CPU stack, the network stack, the storage stack, and what it's doing with memory. Once you can figure that all out, we can actually tell you deterministically how the application is performing. You have a reference point. You can use tools like Joey suggested before, some of the other ones, Perfmon, our capacity planner, vCenter operations. We'll do dynamic baselining. We'll talk a little bit more about that. But effectively here, we want to make sure that the data we collect is used for sizing, is used for comparison, and it's not really to be used for anything else. Those are the couple easy things to do with it. It's not about beating hardware platforms. Let the hardware vendors kind of play out what they need to do there, follow their benchmarks, but make sure that you're looking at what's important to you and your business to do those comparisons. And like Joey said before, what's important to you? If you're worried about your application doing transactions per second, measure that as part of your baseline. Maybe that doesn't come out in Perfmon. You're going to have to find some way to collect that. But critically choose the important items. No response times. And basically, these become your success criteria. So when we baseline, you set up a test. You set up what you're going to collect that's important to you. And you grab that, and that becomes your data point. So then let's migrate to virtual infrastructure. Let's migrate to a different platform. And effectively, very, very important tips here too, use the latest platforms. I have many clients out here as I roam North America that are still doing big workloads on older servers, expecting them to perform, and that's just not obviously appropriate. Right-size the virtual machines. Just because you can build a 32-way VM, what's the point of benchmarking a 32-way VM if you only need 2 or 3 or 4 processors? Right? So size the VM appropriately. Size it realistically. Do things like an iterative approach. Test an application, collect a baseline, add a virtual processor, recollect it, see if you actually get a performance improvement, size up appropriately, kind of iteratively. And then use other tools too, like Capacity IQ, that can potentially watch for oversize and undersize. But the whole trick here is now that you've determined what you want your application to do, put it into the environment, and we'll test against that. And Joey kind of touched on this, and I'll harp on it again, because if you take away nothing from these performance sessions, it's the focus on storage, just because it is a very prevalent issue out there. And the fact is, storage can be complicated. We need to look at from disk spindles right up to file systems inside those VMDKs. And you need to know, for performance analysis, for benchmarking, for tuning, that entire stack. We need to know how many spindles are put together. We need to know what the array is doing for cache. We need to make sure that the ESX host, we're either using our file system, maybe an RDM that way. At the virtual machine layer, how did you provision that disk? Is there a snapshot on that disk? Is that disk aligned? All of these pieces in the stack will affect performance. So as you migrate the application into the world here, time spent here equals success. If you get the storage stack right, performance of an application is almost a non-issue today. And then, like I said, circle back. So now that we've baselined it, now that we've migrated it with a focus on storage, let's go back and measure now what it's doing. Are we using more or less resources? Is the system running more effectively? Let's compare the metrics that we collected for directly against. Do they meet or exceed? And I'm willing to bet performance is always going to be better. You're always going to exceed. And it's a property of moving from an older hardware platform to a newer one, or, the application didn't exist, and so this is your initial baseline, or initial performance baseline. But the other piece to this is don't just you collect this data and put it in a spreadsheet somewhere. You need to follow back up with the business, right? These are the real owners of the applications. So benchmark data is important to them to show that their application is a success, that you helped them generate that. This is data to be shared. And last but not least, we need to continue to monitor this ongoing performance. So performance management is a little bit different than benchmarking. Benchmarking is generating that baseline, figuring out where you need to be. But what happens when we add one more workload to that environment? What happens when one more VM is sharing that LUN somewhere? What happens when we add a couple more VMs and network traffic is shared out a different route? The environments are going to constantly change, so you're all constantly going to have to monitor this. So is anybody scared now? How do we do that? Well, I'll answer that question right away. Let's skip this data point. vCenter operations. Now, who here has had a chance to look at vCenter operations or attend a session on ops out here at the show? Great. For everybody else that hasn't yet, I do honestly strongly encourage you to go check it out. And it's because I call it dynamic baselining at its best. The fact is, we all have trouble today now that we migrated that application, and we used to know how it performed, and it changes, and we get that call. Something wasn't working on Friday. You come and not just from a reactive thing like that phone call, but the fact is, hopefully, a tool like this is going to alert you that disk contention went up. You're going to start getting phone calls right away from the database guys. But it's able to monitor a dynamic environment. That's what's kind of critical here. Learn a behavior and monitor that behavior in a changing environment. So very crucial for the success of application performance. Benchmarks mean nothing if we don't continue to operate the environment correctly. So back to this other data set here. This is a couple more points I just want to throw. We did a survey back at the beginning of 2010 that said, what kind of percentage applications are being moved to the virtual platforms. We looked at some Microsoft stuff, we looked at some Oracle, we looked at some SAP, and then we redid this survey in April here, and these are the interim results. The fact is, everybody continues to move big applications into the virtual space. Again, because we think we have good data, we have good methodology, we can continue to monitor and manage these environments. And it's a diverse set here too. ERP, database, messaging. And in my mind, these are the biggest challenges we can have. So if we're continuing to see our peers grow this, we're continuing to put massive numbers out there because of benchmarks, what I want you guys to take away is the fact that it can be done and that we can demonstrate that in many, many different facets. So kind of rounding it out here, we'll take some questions right away, but I want you to leave with benchmarking as a science. Benchmarking is a career for many people, and it's not something that should be undertaken lightly. I get a ton of calls from people saying, hey, Mark, I put an application in, I benchmarked it, and something's not working right. And after about 15 minutes with them, I can tell you there's no methodology, you couldn't reproduce the result. Let's make sure we respect that and try to basically duplicate it. If we want to benchmark something, we need to abide by the science and methodology that's there. Good benchmarking provides very accurate comparisons. So here again, if we don't do it right, we completely invalidated all the data. If you're using a different server, a different configuration, like Joey said, different software stacks, we can't directly compare those. We always have to ask the question and challenge the data. And again, for decision-making confidence, it proves that the platform's more than capable. And like I highlighted before, we need to start to take into account that in the cloud, in virtualization, in our environments, the behavior is going to change. And we need to find a way to manage that and to monitor that. And that as you saw all these tools through the session here, you got to find the right tool for the right job. Which means, if you're testing messaging, You have to use an appropriate benchmark, something that's, again, universal. You just don't necessarily make one up on your own. Right tool, right job. And with that, I figured we crushed a lot of stuff in here, and we wanted to have a little time for Q&A. So anybody has some questions, if you can pop up to the microphones that way, obviously we'd love to answer anything for you. We could. Any brave souls? Oh, I thought for sure I was going to get beat up on something. Yes.
Okay. Curious, why don't you use IO Blazor in your benchmarking?
Why don't we use IO Blazor?
Yeah.
In fact, we absolutely could. It's one of the tools we have in our box. I know it's one of our VMware flings developed by one of our guys. We tend to see Iometer as a bit more of a multi-purpose tool out there people have used for years. And it's not that it does a better or worse job. It was just something that I think speaks to the people more. More people have experience with it.
Okay.
Thanks.
Sir.
Does the VMmark offer SDK or API for us to use it if we were to decide to write our own testing program to integrate it with our application?
I don't believe it does. Joey Lee, no. Basically, the harness, the benchmark was designed to do one thing. The harness is designed to do one thing. We don't have any other exposed interfaces in it that I'm aware of to allow you to do something different with it. And again, coming back to a good benchmark, it needs to be repeatable. So could you use building blocks in there to build your own custom benchmark? Sure. But it's not something you're allowed to directly manipulate, no. You bet. Sir.
Yeah, is there a roadmap yet to go beyond 32 vCPU? Is that on the horizon?
Sorry, could you repeat the question?
Is something beyond 32 vCPU as the Mac supported?
Right. So is there a future for pushing
64,
beyond the 32-way?
48, 64 or something?
I'm not allowed to say because they'd lynch me and throw me in the closet and things like that. But if I were a guy out there, I would think that, yes, we will absolutely see greater scalability. One of the things that VMware very proudly does is QA the environments excessively. So the fact when we push 32-way and we put that up there, we have a number of very strong examples to do that. I believe there are some other competitive platforms out there that can set a maximum, and we can change ours too, but nobody's ever tested to that upper maximum. Coming soon to a theater near you. Yes, sir.
Hi there. I was wondering if it's possible to make a set of appliances available to build up the tiles. I know you couldn't cover Windows, but possibly all the other ones like the benchmarks that are freely available, just to speed up for a customer to do the benchmark, because I agree, it takes a lot of effort and time to build up the bench, so to speak, to do the benchmark. Is there any use case for that? Because
the trick with some of that one, and do you know if we're going to release any pre-configured appliances
I think
that
there's
way?
already quite a few pre-configured ones, the ones that we can provide.
As appliances?
Not as appliances, but as templates,
yeah.
importable templates.
Okay.
The problem is some of it, it needs to be licensed another way. We're not allowed to kind of distribute it in that fashion. And it's one of those things that, unfortunately, that's part of the setup effort. Our team does it so frequently. We have all the templates in place. And that's why we encourage you out there, respect the effort to kind of put it in, because, unfortunately, I don't think we're going to distribute it in a different fashion that I'm aware of.
Okay, thank you.
You bet. Sir?
Do you have experience with Orion benchmarking, that Oracle tool, versus Iometer?
I don't.
I do not, no, not on Orion.
Oh, really? Thank you.
If you pop up to the front here, let me take away a card there and let me reach out to you, see if we have somebody that might have some experience that way could speak to it. Sure, perfect, excellent, thank you. Sir?
vCPU allocation in a multi-tenant environment is very difficult, especially with servers with 2 or more vCPU requirements. Is there any white papers out there or any type of use case scenarios that could be beneficial? Everything I've scattered on the net, it's more of just opinion statements.
And, okay, let me see if I got the question correctly. So you're looking for basically multi-vCPU assignment in a multi-tenancy environment and
Correct.
practices around that.
Yes, so it's ever changing. I'm constantly adding Exchange servers, SQL servers, everything else, multiple clusters, and vCPU ready is something that's very challenging, those values going above thresholds. How can I maintain that on a recurring, just ongoing basis?
So you're right. It's an interesting challenge because it's a bit more of an operational one than a technical one, because it's about managing the capacity or the capability that's still available and then monitoring it every time you add more to the tenancy or a multi-tenancy space. So a tool, something like a VC operations or vCenter operations that way, is going to be able to kind of allow you to see the change in the environment, the addition of a workload, and the impact it has overall on some of those values, to the point where there's some good thresholds that should be set somewhere. Ready time is, a 10% per vCPU situation, that when you hit that, your host contention, and unfortunately that means the capacity system should be telling you to spin up another box.
Okay.
Does that kind of help?
Kind of, yeah. I mean, typical, looking at the clusters, the even peak utilization of CPU overall doesn't normally exceed 30+%. It's just the contention with having to present multiple vCPUs to several virtual machines. It just seems as though I've got all this processing power up here, but they're still all fighting over it. So is there a tool that I could use to better manage?
That, again, I kind of defer that to vCenter operations, because in that case, yes, the host is not out of processor power, but we've still created contention in scheduling because of the number of vCPUs to pCPU that happens in that space. And unfortunately, that does become a limitation at some point as we oversubscribe. I'd be interested to hear kind of your values. I see sometimes 6, 8, 10 vCPU per pCPU, vCPU to pCPU. And above that, obviously, that is going to be a challenge. And that, unfortunately, becomes one of the design parameters in, say, the VCDX world. When I see these designs, one of the questions I'll always ask is, how well can we utilize that host? Maybe we don't need a 4-way host because I'm never going to get to it. I'm going to turn my building block into a 2-way, or I'm going to use slower clock frequency boxes to make it more economical. So it's definitely a property of watching the impact, but then designing around what you can do. In the multi-tenant environment, oversubscription is key. I get it. That's how you make money, right? But
Sure.
It becomes the tipping point where we can't oversubscribe so insanely, nothing can get done. And there's no direct tool that's going to help you with that. I think it's an iterative approach using a vCenter operations and a review of the design occasionally.
Very good, thank you.
You bet.
Would you know the differences in NFS performance between version 4.1 and 5?
Differences in NFS performance. We don't have anything published on that. We have experimental data that's being generated right now. Expect something soon, I've been told, probably within the next month or two. The intent is, again, on vSphere 5, we've really focused on NFS as protocols being more heavily adopted much quicker than, say, an iSCSI. And the focus around that is around reducing latency. And by doing that in our stack, we're increasing throughput. So I don't have any exact numbers for you, but I do know there's a very positive improvement there.
Okay, thank you.
You bet. And 10 gig is always a good thing with NFS, yeah. Oh, okay, excellent. Perfect. Anything else? Well, the few remaining, I'll be off to the side if you have any questions for us, but thank you guys very much.